Week 1, Chapter 1 and STEM Electronics and IoT Remote Instructor Training. Chapter 1 Overview. These are the Chapter 1 sections and objectives. You should read Chapter 1, review this video, complete the required labs and lab reflections, and take the Chapter 1 exam before continuing on to the next chapter. Complete Packet Tracer Lab 1.2.2.5 and the lab reflections. The start file is located in the Downloads folder. In this lab you will locate and add components, wire the components together, and review the programming. You will notice the battery will drain fairly quickly. What has caused this? See if you can find ways to fix it, like add other components or changing the environmental variables. Complete Packet Tracer Lab 1.2.2.6 and the lab reflections. The start file is located in the Downloads folder. This lab will introduce you to the microcontroller or Arduino device in Packet Tracer. STEM Electronics and IoT Chapter. These are the STEM Electronics and IoT chapter sections and objectives. You should read the chapter, review this video, complete the required labs and lab reflections, and take the chapter exam before continuing on to the next chapter. There are two types of currents in use today: alternating current, AC, which is used in motors and household devices, and direct current, DC, which is used in electronics and computers. This course only requires the use of DC current. All materials are made up from atoms, and all atoms consist of protons, neutrons, and electrons. Protons have a positive electrical charge while neutrons have no electrical charge and electrons have a negative electrical charge. Atoms are bound together by powerful forces of attraction existing between the atom's nucleus and the electrons in its outer shell. All basic electrical or electronic circuits consist of four separate but very much related electrical quantities called voltage, indicated with a capital V, current, or intensity, indicated with a capital A for amps, resistance, indicated with the Greek symbol omega which stands for ohms, and power, indicated with a capital W. We will look at these in more depth. Voltage is the potential energy of an electrical supply stored in the form of an electrical charge. Voltage can be thought of as the force that pushes electrons through a conductor. The greater the voltage, the greater is its ability to push the electrons through a given circuit. The difference in voltage between any 2 points, connections, junctions, or nodes in a circuit is known as the potential difference or voltage drop. While AC voltage can vary its voltage, AC outlets in our homes generally produce 120 volts. DC voltage produces a constant voltage source. DC voltage, like in batteries or computer power supplies, may use several voltages. Current is the movement or flow of electrical charge and is measured in amperes. It is the continuous and uniform flow of electrons around a circuit that are being pushed by the voltage source. Looking at the diagrams, which one is correct? Answer: both are correct. The conventional current flow was the original train of thought. But now we know the electron current flow is the way electrons actually move in a circuit. Electron flow or negative to positive flow will be taught throughout this course. Resistance is the capacity of a material to resist or prevent the flow of current within a circuit. Resistance is a circuit element measured in ohms with the Greek symbol omega. Note that resistance can only have a positive value. We will use resistance to balance the voltage in circuits and keep from damaging components. And finally, power, measured in watts, is a measure of how much work can be performed in a given amount of time. The combination of both voltage and current in a circuit makes watts. This is how we calculate the wattage of a computer's power supply. Circuits can be series, parallel, or a hybrid of both. Examine the diagrams. In a series circuit, All components are connected to form a single path for electrons to flow. In a parallel circuit, electron flow could have multiple paths. In a hybrid circuit, some components may be shared by several series circuits. Common IoT components. A resistor is measured in ohms and is classed as a passive circuit element and as such cannot deliver power or store energy. Instead, resistors absorb and dissipate power as heat and light. Notice the schematic symbol for a resistor. It usually has two markings, a label to track the component like the R1 marking, and a size measurement of the component like the 330 ohms marking. We will use three different types of variable resistors in this course: a photoresistor, a flex sensor, or a potentiometer. A variable resistor can change its resistance based on an external variable. A fixed resistor has several markings to determine the size and tolerance of a resistor. They also come as different wattages. You can identify each resistor by its barbell shape and four colored stripes. Kits will include several 330 ohm and 10k ohm resistors. 1/2 watt resistors work best with breadboards. Some kits come with small wattages and may have to be doubles to make a good connection on the breadboard. A diode is an electronic component that only allows electricity to flow through it in one direction. Its primary role is to route electricity. They have an anode, the positive side, and a cathode, the negative side. They are polarized, meaning current only flows from the cathode to the anode and never the opposite direction. This diode can be identified by its small size, orange interior, and black ring on one end. There are probably only one or two in your kit. Light-emitting diodes, LEDs, convert electrical energy into light. They are polarized, meaning they have an anode, positive side, and cathode, negative side. It is a common mistake to reverse the LED, which causes it not to work properly. LEDs can be identified by the color and different length connectors. A relay is an electrically operated switch. Many relays use an electromagnet to mechanically operate a switch or solid-state relays. Please note, the relays we use in the lab do not fit the breadboard very well. I suggest you solder a short solid core wire to each of the 5 terminals to facilitate a better connection. We will use a single pole, double throw sealed relay. It can be identified by its rectangular shape and 5 connectors. A transistor is a semiconductor device used to amplify or switch electronic signals and electrical power. There are many different kinds of transistors available. You will find only one transistor in your kit. It can be identified by a round back, flat front, and its 3 connectors. There are 2 types of transistors available, the NPN and the PNP. The only difference between an NPN and PNP is the direction of the arrow on the emitter. The arrow on an NPN points out, and on the PNP it points in. We will use the PNP transistor in our labs. An actuator is a component of a machine that is responsible for moving or controlling a mechanism or system. It requires a control signal and a source of energy. The control signal is usually low energy and may be controlled through electric current, pneumatic, or hydraulic pressure. A servo motor is used to provide control of a desired operation through the use of feedback. The servo in your kit is rectangular in shape and has several different interchangeable cogs. Math in electronics. It's important to know the math behind our circuits so we won't damage any components. It's important to be able to convert different units to another in our math formulas. Notice the units increase and decrease by 3. Positive numbers mean to multiply by 1000, or move the decimal to the right 3 places. Negative numbers mean to divide by 1000, or move the decimal to the left 3 places. It's common to go from watts to kilowatts or amps to milliamps. You should always get to the base before using any other calculations. The relationship between the voltage, current, wattage, and resistance forms the basis of Ohm's law. As with the current flow, the formulas can be taught with traditional or electronic versions. I would recommend using the electronic version of the chart. There are 12 variations of Ohm's law. As long as you know two values, you can calculate the other two. This is just another way to look at the same chart. As stated before, as long as you know two values, you can use the correct formula to calculate resistance, current, voltage, and power. The power law describes the relationship of voltage and resistance to calculate watts. Any of these three formulas can be used to find power depending upon the known variables. These are the formulas we use to calculate the size of a power supply. Notice all three variations get the same answer. Kirchhoff's laws look complicated, but they aren't. Simply they mean what goes in must come out. Voltage or current will always calculate out to equal 0. You always want to assure you output the same current and voltage you input. For example, if you have a 5-volt battery, then you want to have sufficiently sized components to use all 5 volts. Power within an electrical circuit is only present when both voltage and current are present. Generally, electrical power is dissipated in the form of heat, mechanical work such as motors, energy in the form of radiated light, or as stored energy like in batteries. As long as you know two of the variables, you can calculate any of the four values. Look at the formula in red. You can use Ohm's law to calculate the size of a resistor for a LED. Resistance equals the source voltage minus the LED voltage divided by the LED amperage. This is why Kirchhoff's laws are important. Components can be destroyed if not calculated correctly. So from the previous page, we needed to know the voltage of the LED. This chart tells you the values to use to make the calculation. Although there is a tolerance range for each color LED, use these values to get a consistent resistor result. Notice all 5mm LEDs have a 20 mA current rating but different forward voltages. Calculate the size of the resistor needed for each of these problems. A 9-volt battery with a 5mm red LED will calculate as follows. The 9-volt source minus the 2.4-volt LED equals 6.6 volts. Divide 6.6 volts by 20 milliamps or 0.02 amps to get a 330 ohm resistor. A 5-volt battery with a 5mm red LED will calculate as follows. A 5-volt source minus the 2.4-volt LED equals 2.6 volts. Divide 2.6 volts by 20 milliamps or 0.02 amps to get a 130 ohm resistor. Here are some additional resources where you can find information and worksheets on all the materials covered in the PowerPoint. This lab is part of the Remote Instructor Lab Manual. Use this PowerPoint and the STEM Electronics and IoT chapter to help you complete this worksheet. Once you have finished, you can use the key on my instructor website to check your answers. There is no lab reflection for this lab. You will complete labs 1.2.2.5, 1.2.2.6, 1.3.1.1, and their respective reflections during week 1 of your training. If you have any questions, please feel free to contact me.